Hello friends, welcome to our channel Engineering and Technology for You. In today's video, you will learn enabling, disabling and masking of 8085 interrupts. Basically, you are going to study the instructions DI, EI, SIM and ring. Let us start with the enabling of interrupts. All the hardware interrupts except trap are disabled when the processor is reset, and they can also be disabled by executing the DI instruction, that is nothing but disable interrupt instruction. In order to enable or to allow the disabled interrupts, the processor has to execute EI instruction. EI means enable interrupt. This instruction is used to enable all the maskable interrupts RST 7.5, RST 6.5, RST 5.5 and INTR. Then let us see the disabling of interrupts. The mask interrupts RST 7.5, 6.5, 5.5 and INTR are disabled by any one of the following operations. First is system or processor reset. Then second is after recognition or acceptance of any interrupt, the interrupts are disabled. Then third is executing the DI instructions. So these are the three ways of disabling the interrupts. Now let us see the disable interrupt instruction. This instruction resets the interrupt enable flip-flop and hence disables the RST 7.5, RST 6.5, RST 5.5 and INTR interrupts. In the previous video, we have seen the detailed diagram of the structure. So in that we have shown the flip-flop which is reset by the DI or disable interrupt instruction. Then let us see the masking of the interrupts. The 8085 provides additional facility for RST 7.5, RST 6.5 and 5.5 using the SIM or set interrupt mask instruction. The status of these interrupts can be read by executing the ring instruction, that is read interrupt mask. Now first the unmasking of RST 7.5, 6.5 and RST 5.5 interrupt can be performed by moving an 8-bit data to accumulator and then executing the SIM instruction. So this SIM instruction, let us go into the details of this. This instruction is used to enable, disable the RST 7.5, RST 6.5 and 5.5 interrupts. It transfers the control word from accumulator to the interrupt control logic and the serial control logic. It is essential to load the SIM format control word into the accumulator before execution of the SIM instruction. Then let us see the SIM format. Here you can see the SIM format. The bits D0, D1 and D2. These are the RST mask bits. This is for RST 5.5, this is for RST 6.5 and this is for RST 7.5. If this bit are 1, then the interrupts are masked. If it is 0, then the interrupts are available. Then this MSE, mask set enable, if it is 0, then bits 0 to 2, that is D0, D1 and D2, they are ignored. If it is 1, then we can set the mask according to the bits D0 to D2. Then this bit, it is particularly for the RST 7.5 interrupt. It resets the flip-flop of RST 7.5. Then this bit is not used and this is serial data enable. So if it is 0, will be ignoring the serial data. If it is 1, then send bit 7 to SOD pin. So this SOD bit, that is serial out data, this will be going to the SOD pin with the help of this. So this is the format for SIM instruction. Let us understand this with the help of example. Let us take the example. Set the interrupt mask so that the RST 5.5 is enabled, RST 6.5 is masked or disabled, and RST 7.5 is enabled. So here first we have to enable 5.5. So bit D0 is 0. So we have put it here 0. Then disable 6.5. So bit D1 will be 1. We are putting it here. Then enable 7.5. Again this bit will be 0. Then allowing setting the mask. So this MSE bit will be 1. Then do not reset flip flop. So D4 is 0 here. Then bit 5 is not used, so we have kept it 0. Then do not use serial data. So SD we are making it 0, and serial data ignored. So that is also again SOD is 0. So the contents of accumulator will be 0A, 0 0 0 0 1 0 1 0. Now this control word or the contents of accumulator, if you load into the accumulator and then use the SIM instruction, then the RST 5.5 will be enabled, RST 6.5 will be masked, and RST 7.5 is again enabled. The program for this is given here. First we have to enable all the interrupts so that we can use them. Then we have to load accumulator with 0A. That is the control word or the format for which we have derived just now with the help of this. Then we have to give the instruction SI. So in this way we have to use the SIM instruction for masking the RST 7.5, 6.5 and 5.5. Then let us go to the next, that is the read interrupt mask, RIM instruction. This instruction is used to check the status of all pending and maskable interrupts. It can also transfer serial data bit from serial data line SID to D7 bit of the accumulator. This instruction transfers the content of interrupt control logic to the accumulator. So it is just opposite to SIM. Here the contents of interrupt control logic is transferred to the accumulator. Hence accumulator is loaded with the status format after the execution of RIM instruction. So let us see the format for RIM instruction. Now again the bits D0, D1 and D2, they are for the RST mask bits. So if they are 1, that means the interrupt is masked. If it is 0, that means the interrupt is not masked, it is available for use. Then this IE bit D3, that is interrupt enable, value of the interrupt enable flip flop. If it is 1, then INT flip flop is set. If it is 0, INT flip flop is reset. So it just gives the status of the INT flip flop. Then this D4, D5 and D6, these 3 bits are for the whether the interrupt is pending or not. So this is for 5.5, this is for 6.5 and this bit is for 7.5. If these bits are 1, that means that particular interrupt is pending. For example, D4, if it is 1, that means 5.5, RST 5.5 is pending. So in this way these 3 bits are used for knowing whether the interrupt is pending or not. Then the last bit D7, it is for the serial input data, SID. So it will be coming to the accumulator after the ream instruction. With this we come to the end of this video. If you have understood the video and liked the video, please press the like button and share with your friends, and subscribe to our channel for more videos on 8085. The next video will be again on interrupts regarding the process of the vector and non-vector interrupts. Thank you.